So let us continue with this part. So for this part, we still have problem solving to do. So of course, let's look at question 4 first, just to recall back the situations, and before we move on to something else. We still have something to learn actually, but let's for warming up purpose, let's look at this. The marks for mathematics in the common trial examination in a district are normally distributed with a mean of 62 and a standard deviation of 8. So these two information are important. So we write it down in this way. So the mu is 62, the standard deviation is 8. Okay, so of course you can also write like this if you want, but this is not compulsory. X is normal distribution, X is normally distributed with mean 62, and then variance is 8 power 2. So you can write like this also, which is kind of common to write like this. Then find the percentage of students who obtain grade A with marks of more than 74. Okay, so that means we have to find out the probability for X more than 74. So we have to change it to z-score first before we can use the table. So we change it like this: P Z more than 74 minus 62 over A. Okay, then after that, P Z more than, okay, so we have 8 over A, end up with 1. Okay, so of course when you look at the graph of this z-score, you know this is standard graph. The maximum point of the bell-shaped graph is at the y-axis, at the vertical axis. So this is called fz. Z, 0 is here, so 1 is here, more than 1 is here. So to find the probability of more than 1, so we look at the table. So this is the normal distribution table. Okay, so more than 1, try to recall back also, our table will help us to find the area on the right hand side of the z. The z is here, so it's on the right hand side of the z. So our situation is our z-score is 1.0, so we can take this value straight away, 0.1587. Okay, 0.1587 is the probability here, 0.1587. So that is the probability, 0.1587. So this is area on the right, so that's why we are not going to do anything extra. You can get the answer straight away. So this is part A. Now we look at part B. Oh yeah, one more thing. Our question, right, want us to put the answer as percentage. So this is probability and it is in decimal. So to put it in percentage, we just need to multiply with 100. So in percentage, multiply with 100, 15.87%. That's the answer straight away. Okay, now we look at the next part, part B. Find the percentage of students who fail with marks less than 45. So fail, marks less than 45. So we change it to z-score. So the formula is X minus mean over standard deviation, which is 8. Okay, then after that, we just need to simplify the fraction there. 45 minus 62, negative 17. Negative 17 divided by 8. So we get negative 2.125. Okay, so for this kind, we look at the graph first. Again, I draw the bell-shaped graph, fz versus z. negative 2.125 is on the left of the vertical axis, less than it. Okay, so I hope you still remember the previous lesson where I say that when the z is positive value, it will help you to find the region on the right. But if your z is negative value, it will help you to find the region on the left. Okay, so it is negative value now. And when you want to look at the table, you just look at 2.125. No need negative. Okay, no need negative. So 2.125. Okay, so which means 2.1, 2.1, and then 2. Okay, will be this value. 2.125. Okay, so the 5, and then we look at the same row. Okay, go to the corresponding column. So we have 2 there. I circle up first. No, not this. Okay, the 2 up here. Okay, so we need to minus 2. 0.0170 minus 2. So 0.0168. So that's the probability. Okay, 0.0168 is the probability. So that is the standard question. So a standard question like this is where mean is given, standard deviation is given, then they ask you to find probability. So this is just the what we call the ordinary question. Nothing special one. Just follow the normal step where you change it to z-score, then you use table to find probability. So ordinary question. Okay, now let's say we look at part E then. Part E. Solve each of the following problems. Okay, so let's see the example here. A school in Sarawak starts at 7 o'clock in the morning. On a particular day, the times at which the student arrive at the school are normally distributed with mean 0.645 hours and the standard deviations of 8 minutes. Okay, so determine the percentage of students who are late. Okay, so students who are late. Okay, now I write it down first. So first of all, we need to know that. Okay, so we need to know that mean is 0.700. So that is the no, it's not. The mean is 0.645. So 0.645. Okay, the mean is the time. So and then the standard deviation. The standard deviation is 8. Okay, 8. Okay. Now after that, what we need to do is 0.645 is a little bit hard to be used. We need to know that 0.645. Okay, so it's a little bit hard to be used here because this is timing. Okay, so we need to do something to change it. Let's say I change it to because the standard deviation is in minutes, right? Okay, it's in minutes, so I try to make it in minutes also. 6 hours 45 minutes. Okay, so let's see what to do first. We look at A first. Determine the percentage of students who are late. So when I see percentage, I just remember just now for this we have to change it to percentage also. 1.68. 1.68. Okay, so percent. So now again we have to change this to percent after we found the probability. Okay, so if you are late, that means your time is more than 0.645. So no, if you are late, that means your time is more than 7 o'clock, because the school time is 7 o'clock. More than 7 o'clock. Okay, so we know that everything is in minutes. Is in minutes. So because of this, let's put it in this way. We want to change it to z. I want to change it to z. Pz more than 7 o'clock minus 0.645 over standard deviation 8. Okay, so Pz 15 minutes. 7 o'clock minus 6:45 is 15 minutes. 15 over 8. So 15 over 8. Okay, now 15 divided by 8, we get 1.875. So now let's see the graph. So the fz is here, the z is here, 1.875, more than it. Okay, so let's look at the table now. Okay, so I write away the previous one first. 1.875. Okay, so first 1.8 here, followed by 7, 1.87. Okay, so this one, five. So 5, mark the corresponding value. 1, 2, 3, 4, 5. Okay, this one. So 0.0307 minus 4. So it is going to be 0.0303. Okay, so 0.0303. So we got this. And after that, we have to know that they want percentage. Okay, so in terms of percentage, you just multiply with 100, your probability 3.03%. So this is part A. Okay, now we look at part B then. Part B. Okay, part A is normal, normal questions, ordinary questions. So part B is something different already. So let's take a look. So the questions. Given 50% of the students arrive at school between the times T1 and T2, find the probability of T1 and find the values of T1 and T2 such that the time interval between T1 and T2 is the shortest. Okay, so it's the shortest. So this seems to be like different from the normal already. They give 50%. So 50% is 0.5. So we can take it as probability, something like this. T1, T2 is 0.5. It's 0.5. So that gives us probability, and then we need to find out T1 and T2. Okay, so what should we do? We change it to z-score first. T1 minus, with the mean, 0.645 over the standard deviation 8. T2 minus 0.645 over the standard deviation 8. equal to 0.5. Okay, so once you get this, now what we need to do is we have to okay, you imagine about the graph first before we look at the table. Okay, before I look at the table, you imagine about the time first. Okay, the graph. Okay, so if you look at the graph, right, which is like this, fz, z. Okay, so they say shortest interval. Shortest interval, T1 and T2 is the shortest. Okay, so first of all, when you look at this graph, right, we need to know something like this. The total area under the graph, total area is something like this. If I go and find out the total area under the graph, it is going to be 1. It is going to be 1 because total probability is 1. Okay, total probability is 1. So total area under the graph is also 1. Okay, so now 0.5 seems to be half of the whole mountain. So imagine that 0.5. I draw the same graph again. So if I take half of this graph, so you should expect here to be 0.5. And again, if I take the other half of the graph, so we should expect here to be 0.5. So that is 0.5. Okay, 0.5 represent half of the graph. Half of the graph. Okay, so if you are thinking whether we can just take half of the graph like this or not, let's see. I draw the graph like this. Can I assume that my first fraction, this one, T1 minus 0.645 over 8 to be here, and T2 minus 0.645 over 8 to be the right hand side? Okay, just imagine first. T1 minus 0.645 over 8 to be here, and then T2 minus 0.645 over 8 to be on the right, and then here take 0.5. Is that okay or not? So it seems to be like okay, right? But the thing is, this fraction has to be as right as possible. So at the end, it makes T1, T2 to be very far apart. Very far apart. Okay, so the question said T1 and T2 must be the shortest. So we can't take it in that way because at the end, T1, T2 is going to be very far apart from each other. If you take here and here, as right as possible, just imagine that. Okay, this is as right as possible. Then at the end, these two T1, T2 are very far apart, which is not the shortest interval. So in what situation we can have the shortest interval? So you just take it like this. The idea is area under the graph. So area under the graph is the greatest somewhere in the middle, because the graph going up a lot, right? So to reach the maximum, so it is going to be shortest interval if you take area in the middle, something like this. T1 minus 0.645 over 8, T2 minus 0.645 over 8. So if you take middle, then here to here will be the shortest. Okay, will be the shortest. That is the main idea of this question. You take middle. Why you take middle? Then here and here will be the shortest, because the area covered is a lot already. Okay, it's a lot because the area under the graph represent probability, right? The graph is so high up and it cover up 0.5 with a very small difference between these two values. So it has to be in that way in order to have the shortest interval between the two fractions. Okay, so if that is the case, that means we should expect, in the middle is 0. In the middle is 0, the z-score is 0. Okay, so we should expect these two values to be the same value but opposite sign. Something like for example 0.1 and negative 0.1, something like that, So we can also say that in order to have the shortest interval, the area over here should be 0.25. The area over here should be 0.25 as well, which is the half of 0.5. Okay, so if that is the case, right, then the graph is symmetry. The graph is same on both sides. So if you take 0.5 and 0.5 in the middle, so we should expect the other two end also 0.25. Okay, so now when you want to check table, you have to know that our table, you look at our table again, okay, you have to know that our table will only give area on the right. So you have to refer to this value, which is area on the right, which is 0.25. So you use 0.25 to find the z-score, and that is something new. You use the probability to find the z-score over here. Okay, let's see how. Okay, you look at the table again. So remember the value just now, 0.25. You use probability to find the z-score. So probability is the value over here. All these are the probabilities. The z-score, the first decimal here, and then second decimal, and then third decimal. The z-score is either on top or at the side. Okay, probability is in the middle. Now we want to find probability on the right to be 0.25. So we look for 0.25. By the way, the values are big to small. Okay, so the biggest value given is 0.5. So 0.25 just go down a little bit. And you can see, okay, let's zoom in a bit. Okay, so you can see values about 0.25, but it is not exactly 0.25, it's 0.2514. This is 0.2483. This is smaller than 0.25. This is greater than 0.25. Exactly 0.25 we don't have. Okay, but it is okay. We can just minus, So 0.2514, we need to minus away the 14 at the back. Okay, so this column is where we can minus. Okay, so we have to minus 14. So let's look for 14. We don't have 14 exactly, but 13 is the closest. So we take 13 then. Okay, so imagine it's 0.2514 minus 13 for the last two digits. It will end up with 0.2501, which is very close. The closest already. Okay, so we can't have any case that are closer than that. So we will take this. And how we take this? We take it by reading the z value at the side, 0.6, on top 7, that's the second decimal. So now 0.67, and then the third decimal is above of the 13, which is 4, 0.674, 0.674. Okay, 0.674 is the z-score. So that means our situation now is, from the table, when here is 0.25, here is 0.674. So that's the z-score. That is where we do it in the opposite way. We take the probability in the middle and read the z-score at the side. Okay, 0.674. Okay, now let's come back to our question. So we know that this is going to be 0.674 and this is going to be negative 0.674. Okay, so now we continue. Okay, so T1 minus 0.645 over 8 negative 0.674. T1 minus 0.645 equal to, okay, we need to multiply with 8 first. Negative 0.674 times 8. So that is going to be negative 5.392. Remember this is in minutes, in minutes. So T1 is, okay, so imagine the time is 6:45, something like 6 hour 45 minutes. Now you need to minus 5.392 minutes. Okay, so that means 45 minutes minus 5, so it's going to be 40 minutes. So 06 hours 40 minutes. You minus 5 minutes, right? So T1 should be 0640. 0640. Okay, now T2. Okay, let's find out T2. We take the fraction T2 minus 0645 over 8, 0.674. Okay, so T2 minus 0645, so we have to times 8 now. 0.674 times 8, so we get 5.392. That means we have to plus 5 minutes. T2 equal to 06 hour 45 minutes plus 5.392 minutes. That means plus 5 minutes. It's around that. 0650 plus 5 minutes. Okay, so we get the shortest duration. So which is shortest interval. So just 10 minutes interval only. 6:40 to 6:50. So this is the time. So we have done the questions together with the explanation. Okay, so we have done for this. Now let's move on. Remember our new technique is use probability to find z-score. So let's see more example like this. Okay. Now let's see. Question 1. The height of the student in a school are normally distributed with mean 160 and a variance of 169. Okay, be careful. Now they give variance. So you can write like this if you want. N is normally distributed, mean 160, variance 169. But when you use it for calculation, we need mean. We don't need variance. We need standard deviation. Standard deviation is 13. Okay, so now part A. Find the percentage of students whose heights are less than 165. Less than 165. So we change it to Z. 165 minus mean over standard deviation. So we have 5 over 13. 5 over 13, we change it into decimal. 0.3846. Okay, now imagine the graph. Z versus Z, 0.3846, and we want less than that. Less than that means area to the left. Our table, right, can only find area to the right of positive Z value. Okay, so let's look at the table. Okay, I'm going to put the table here. Okay, so this is the table. Now our value just now, 0.3846. Okay, 0.3846, right? So we round off to 5, 0.385. And we read the values. This value, I have to minus with 19. 0.3520 minus 19, 0.3501. 3501. And remember, the probability that you get is probability on the right of the Z-score. It's on the right. Okay, so it's not on the left. 3501. 3501. Okay, so the area, the probability, 0.3501. That's the probability or the area on the right. But we want area on the left, so we have to use 1 minus. Okay, 1 minus 0.3501. So why 1 minus with that? Because 1 is the total probability. So I do it here. 1 minus 0.3501. Okay, then we get 0.6499, but the 1 percentage, right? So 64.99%. Okay, this is just the normal question. They give mean, they give standard deviation. We find probability by changing it to Z-score first, then find probability. Okay, so the new technique that I mentioned just now is they give probability, we find Z-score. It's in the opposite way. Okay, so which is in part B actually. So you see part B. 15% of the students have height more than HCM. So 15% is actually the probability, 0.15. Height more than HCM. Okay, we put it in this way. Probability of height more than H is 0.15. Find the values of H. Okay, so to find the values of H, right, we change it to Z-score first. H minus mean divided by standard deviation 13 equal to 0.15. Okay, then we continue here. Okay, now let's imagine the graph. The graph is going to be like this. Our Z-score is here. This is the Z-score. Our probability is 0.15. So maybe you're wondering, this Z-score is positive value or negative value? Seems to be like not clear. Okay, so we don't know whether this is positive or negative. So we use graph to get the idea. Okay, so I will draw out two graphs. From there you will see the idea whether the Z-score there is, the fraction there is positive or negative. So if it is positive, then it will be here, somewhere on the right hand side of 0. 0 is here. So if it's negative, then it's here, H minus 160 over 13. Okay, so which one is true? So we just imagine on that in this way. when the z is more than this z score, the probability is 0.15. So which means on the right hand side of that fraction, 0.15. On the right hand side, which means here, 0.15. Okay, so the thing is, if the right hand side is 0.15, right, the left hand side should be 1 minus 0.15. So it should be 0.85 here. And likewise, if the right is 0.15, then the left should be 0.85, because the probability can be taking the total of 1 only. Huh? So from here, right, obviously we can see that this is correct, because the big region take the big value, the small region take the small value. This is correct. This is wrong. The small region take a big value, not reasonable. The big region take a small value, so this is not true. This one is correct. From here, from the graph, we can determine. You can draw it out, or you can just imagine only, basically. If you cannot think, you just draw out and think. Okay, if you can imagine, just draw the correct one straight away. Okay, so from the graph, we know that our h minus 160 over 13, our fraction is a positive value. Okay, now we use the table. Okay, we use the table. So remember your graph. When you use table, right, we can only look at the probability on the right tail, 0.15. For positive value, we look at the right tail, 0.15. Okay, so because our table will help us to find the value on the right only, 0.15 is the probability on the right. Okay, so I just write away the irrelevant thing. Okay, now on the right, probability 0.15. Remember, the probability are values inside here, 0.15. Okay, this one, 0.1515. But there is a 15 units extra, so we need to minus with. Okay, let's look for 15. But we don't have 15, we have 14 or 16. So 14 or 16 are just 1 units away from 15. So both will be just fine. Okay, 14 of 16 is just fine. Let's say I take 16. Okay, let's say I take 16. 16 or 14, just okay. Now 1.037. So that's the Z score, 1.037. Okay, we just need to read the side, 1.037 to get the Z score. Okay, so we get ready, we write it down. H minus 160 over 13 equal to 1.037. So we find the H. So 1.037 times 13 plus 160. So we get 173.5. Or they say to the nearest cm. Our original value is 481. So round off to the nearest cm, 173 cm. Okay. So we've settled this question already. So there are more questions there. Okay, now let's see next page first. Okay, so it seems like we have done the whole chapter. As you can see, next page is Spm Practice already. Okay. Spm Practice. Just for your information, this kind of question is also the one that we learned just now. the new skill, they give us probability, you have to find the z-score. You change this to z-score first, then you find it afterwards. So okay, that one is under the same type. Spm Practice paper 2, of course these are the longer question. So you see that it is popular. You see they give percentage, which is probability, then you can find z-score. They draw the graph also. If they don't draw graph, it will be harder. Okay, now let's see the special case like this. Special case like this seems to be like a bit harder compared to the normal one. Okay, so you see this question 3. A study shows that the credit card balance of the customer is normally distributed as shown in the diagram. Find the standard deviation. So how to find the standard deviation then? Okay, so they give us all this information. Seems to be like not the normal way of asking. Okay, so we discuss on how. So first, you need to know that if they give fx versus x, the maximum is actually the mean. Okay, the mean 2680 is the mean. Okay, so we write down the mean is 2680. 2680. Okay, now in order to find the standard deviation, the sigma, basically this symbol is known as the sigma. Okay, so I'm going to make use of the 15.87% on the right. Okay, because I know that our table can find probability on the right. Okay, so imagine from the graph, I know that when the x is more than 3480, the probability is 0.1587. I change the percentage to decimal. Okay, now I change it to z-score first. Z more than 3480 minus mean divided by standard deviation equal to 0.1587. Okay, then I simplify the fraction. 3480 minus 2680 is 800. 800 over sigma 0.1587. Okay, now let's look at the table. So I'm going to put the table down here. (0.1587), which is the probability. So we have to look at the middle to find out the probability. (0.1587), this is the one. 1.00. Okay, 1.00. So from here we know that when you change it to z-score, the graph will look like this. The maximum go to the middle already. 0.1587, the z-score is 1. 1.00, which is 1. Okay, so 800 over sigma, which is the z-score, is equal to 1. So because of that, sigma is equal to 800. So we get the values of standard deviation. Now we look at part B. So we have done part A. So part B, if 50 customers are selected at random, find the number of customers who have credit cards balance between 2005 and 2008. Okay, so we find the probability first. 1005 to 2008. So to find the probability, we change it to z-score minus mean over standard deviation 800. 2800 minus mean over standard deviation of 800. Okay, so press calculator to get values in decimals. Okay, now we get negative 1.475. 2800 minus 2680 over 800. So we get 0.15. Okay, now once we get this, we look at the graph first. Our Z value are negative 1.475 and 0.15, which is the shaded region in between. Okay, so we are looking for shaded region in between. But remember our table, right? Our table, if the Z value is positive, that will help us to find the region on the right, which is the one that I showed in blue. If the Z value is negative value, then the table will help us to find the shaded region on the left. So we just find the two probability on both sides first, then we use 1 minus the two values. Okay, so we start with 0.15. 0.15. Okay, so this one 0.4404. 4404. Okay, so which is the value here? 4404. Okay, for the shaded region on the left, the green color shaded region, we don't care about the negative. We just look at the table and look at 1.475. Okay, so 1.4, 1.47, 1.47. Okay, I mark down this value first. 5. So we need to minus 0.0708 minus 7. So we get 0.0701. 0.0701 is the probability on the left. Now in order to find the shaded region in red color, we do 1 minus 0.0701 minus 0.4404. Okay, so we minus them. Okay, then you get 0.4895. Okay, so we look at C then. Oh no, we haven't finished yet. We just get the probability. Okay, we just get the probability. Now you see the question again. We are not just looking for probability. What they ask is, if 50 customers are selected at random, find the number of customers who have credit cards balance between 2005 and 2008. Number of customers. This is like percentage, 48.95%. So it's like percentage. So 50 customer, 48.95% are having credit card balance of that values. Okay, so in order to find this, we just times 50 times the percentage. Then we will find out the number of customer with this credit card balance. 24.475. So we take 24 because it's number of customer, right? So we don't take decimal. 24 customer. Okay, so we look at part C then. It is found that 25% of the customer have credit card balance less than K. Less than K. 25%. Less than K, 25%, which is 0.25. Find the values of K. So we change it to Z-score. K minus with mean. divide by standard deviation 800 equal to 0.25. Okay, so again, our fraction here, we need to know whether this fraction is positive or negative. Okay, so again, I will draw out both and we use common sense to determine on that. Okay, so I draw out both values. So if that fraction is positive, then it's going to be here. K minus 2680 over 800. If the z value is negative, then it is here. Okay, so z is less than that value. That means our shaded region is on the left. Okay, and the probability, which is area under graph, is 0.25. If the left hand side is 0.25, right, the right hand side should be 0.75. So from here, obviously, we get to see that this should be wrong. Why wrong? Because a big region should take big probability. But end up with this is small probability, this is big. Small region, big probability. Not true. This one true. Small region, small probability. The big region here, big probability. Okay, so this is correct. Okay, so now we get to know that the z-score is a negative value. Okay, a negative value. So remember the idea of negative z-score. It will help us to find probability on the left. So if the z-score is negative, it will find out the probability on the left. Now we have to do it in the other way around. We use probability on the left to find out the negative z-score. Okay, so the other way around. So let's see the table now. Our z-score is negative. We use probability on the left, which is 0.25. So we look for 0.25 in the middle. 0.25. Okay, so 0.2514, this value. The side is 0.6, the top is 7, minus 14. We don't have 14, we take 13. Okay, so now we read the z-score, 0.674. But don't forget, there is a negative. Negative 0.674. We put negative on our own. So negative 0.674 is the fraction. So we form this equation, then we count the z value. So negative 0.674 times 800 plus 2680. So we get 2140.8. And let's see what is K about first. K is about the balance. RMK. So okay, you can take decimal. So if you don't want to take decimal, then you just round off to 4 significant figure. K equal to RM2141. Okay, so just like that. Okay. Now we settle already.